This is customization and modeling on GST 8138. Module 10 lecture. We're going to talk about the change arc in GIS, runtimes, and design patterns. I'm your instructor, Robert Hewlett, and you can contact me via the email address below. The general learning outcome is to master, know and understand all content and concepts discussed in lab, lecture, and the assigned readings. Specific learning outcomes, although not an absolute list, describe the change arc in GIS, distinguish ArcGIS runtimes, describe the MV, MVP, MVD design patterns. So model view presenter, model view delegate. Describe the model view model design pattern, so the one that's used by the ArcPro SDK, mainly because it's built in .NET, and that's the one that .NET uses. Describe the JavaX UI design pattern, right? And that's just how JavaFX separates the user interface and code, how HTML even typically in a larger application separates the user interface and code. How QML, which is a language that's used by the App Studio from ArcGIS, which also ties into the Qt runtime, which we'll talk about shortly, how it separates the user interface and the code, and then sometimes not. Right? So we'll talk a little bit about that. We'll describe the use of the DAML file and the XAML file in ArcPro in the SDK. So these are, if you're going to try out the SDK, and maybe do an ArcPro customization and that, extend the ribbon, then you will be designing, you will be interacting with these files, and who's who and what do they do. So the change arc in GIS. So I have a diagram in Lucidcharts here, but you can watch the video as well. So you can pause my video lecture here and then watch where I go over sort of my personal history with the ArcGIS stack and all the change that has happened along the way, and kind of where we sit today, right? And even like this is ongoing because they're always introducing new technology. So it's always interesting to try to figure out like where are we and how did we actually get here, okay, in that. What I want to talk about now are runtimes, and these are ArcGIS runtimes in that. So we can go, we might click on the ArcGIS site and just go take a look. But basically, I want to start with the JavaScript API, and you're like, well, that's not a runtime. But what you need to know is that a lot of the runtimes are synced to what the JavaScript API can do. So the JavaScript API, there's still two kicking around, 3 and 4. The most current one is 4. 4 is both 2D and 3D. It's been a long time trying to migrate all the functionality from 3 into 4. But the new tools that ArcGIS is building on the web, Experience Builder, and that, the new Storybook site, and they'll have a new Web App Builder replacement as well. So Web App Builder in ArcGIS Online uses 3. In that there's a little bit where it swaps out to 4 if you're doing 3D stuff, but any 2D sort of maps are done in using the 3 API. But the idea is that this JavaScript API, as they call it, kind of sets the bar of what can be done with the other runtimes and that sort of thing. And they do try to keep the runtimes in sync. And we'll talk about that because there's a bunch of runtimes. So what does that mean? But just know that it's usually what's possible in the 4 JavaScript API, or how they structure things, definitely affects the next series of runtimes that we'll talk about. So I like to mention this one because this one is this, although it's not called a runtime, it definitely has an effect on the others. Okay, there's the Java runtime, the 100 version. They used to have a 10 version. I think all the way up to about 10.5, 10.7, in around there. And then they switched over to the 100 version. And the 100 version, the switch would be matching with the 4, right? So all these different runtimes, you can encounter different versions. It depends when someone, you know, pulled the runtime and started building something off of it. You could encounter an app at a practicum or at your work that was built off a 10 version of the runtime. Just know that if it starts with 10, it is, I'll get the laser pointer here, it's probably whatever can be done in the 3, a lot of 2D stuff. But now that we're in the 100, we kind of do what the 4 can do, which means we can get into 3D scenes and stuff. There's a lot more it knows about ArcGIS Online, those types of things. Like, and also in the 10s, in the 3s and the 10s, we deal with something, the map a lot. And in the 100s and the 4s, we deal with the map view, right? And that we've seen that term before in the ArcPro SDK. So when you're dealing with the Java runtime, you could be building Swing applications, which is you know, true and tested user interface architecture on the Java side, but they also have their latest JavaFX as well. And so you could be designing applications with this type of user interface or GUI technology, right? Controls are very different in JavaFX and Swing. It's a very different way of building it in JavaFX as well. And we'll see a little a glimpse of that later on in this lecture. Right now, when you're doing Java applications, then those can run on Windows, Linux, or the Mac OS. So you might be running, but when I say that Windows, Linux, Mac OS, you're really building a desktop application. So think mouse, okay? So you think mouse, you think much bigger screen, lots of real estate. So maybe you have menus and toolbars and you have big icons on your toolbars like the ribbon in ArcPro. It's a very different way of building an app, okay? There's also the Android runtime, so this is for a lot of phones and a lot of tablets, right? And that, so you might run into the 10x and that, but you're probably on the 100, okay? And maybe you're writing in a language like Java or Kotlin. You have choices when you're on Android. Kotlin just kind of hooks into Java. It's like a layer above Java to help you move faster in that. But again, it depends. You know, you could encounter an application that uses ESRI technology that was built on the 10, right? And until you take a look at it, you're not gonna know. So it might be some kicking around still using the 10, but the idea is that maybe they moved up to the 100. Okay, there's an iOS runtime, right? And so in the 10 version, you're probably writing in Objective-C a little bit, but now I think with the 100, you're going to be working in Swift. Most iOS developers have moved on to Swift, but when we first started out, right, they were in this language called Objective-C, right? A lot of these languages are curly braces and that curly brace case sensitive double equal sign languages. They have a very similar look and feel. Okay, there's a .NET runtime, which you're probably going to be using C#. Okay, and so again, that's another one. C# was meant to be a Java killer, so it looks a lot like Java, right? Case sensitive, curly brace, double equal sign, and that semicolon to end the line, all these types of things. So these languages look very similar. You can actually move between them pretty well, and because the runtime is structured the same for Java, Android, iOS, and .NET, then moving between one is half the battle is done, because if you've already worked with map views and maps and ArcGIS feature layers and hosted feature services, then all those objects basically have exactly the same name, right? And what you're really dealing with is just a particular development environment for these tools. Now, if you're using .NET Runtime, you could be building Windows applications, and when I say Windows this way, I mean desktop. So there's the Windows sort of framework, platform framework, and then the Universal Platform Framework. So this would be like if I'm writing for Windows 10. 910. This might be if I'm also doing Windows. I'm doing something in the store, Microsoft Store, but maybe they install it also on a Surface, right? Microsoft Surface. And that. However, they also have another product called Xamarin, in that where you write your code in C#, but it actually can run on Android and iOS, which kind of doubles up on these ones above, right? On these two. Hey, right? But it's just about choices. There's the Qt runtime. You might bump into some 10, yeah, and that sort of thing. But most stuff, is 100. And another way to bump into the Qt runtime is through this other product that Esri has called App Studio. Okay, and it's for you can build your applications in App Studio, and then they'll run on. Let's do the list. Windows, Linux, Mac, iOS, Android. So what you have is like all the big desktop systems, Windows, Linux, Mac, and then the big mobile systems, iOS, Android. Okay, so from this one runtime and development environment, you can hit all these different platforms, which is very interesting. Okay, so I'm going to see if we can actually, if I click here and we can get the tab. So this is the runtime page, the runtime SDK software development kits, and you can see they can get into Android, iOS, Java. But when you're on Java, then you're doing Mac, Windows, and Linux. If you're on .NET, you're typically on Windows, but if you're doing the Xamarin part, you can get onto Android and iOS. And if you're on Qt, basically you can hit everything in that. So we'll just jump back here. So what's new in the 100.8? So this would be the latest runtime. Typically in the summer after the user conference, they'll probably go to 100.9. There's a blog post here that Rex and his friend wrote. Rex has been in the Esri company. I remember being in technical sessions at the San Diego User Conference, maybe early 2000 vintage in there. And Rex was there. So he's been there a long time and he usually deals with these runtimes and these types of integrations in that. So they have a new thing for the utility network and isolation trace. In that, again, at the blog post, they've got some good graphics. Maybe go pop in there and take a look. In that image overlay for scenes, for 3D scenes. So if you want to have like real-time images overlaid, which means that images are changing a lot. And, images got lots of pixels. So to do this, you got to do this quickly, and that sort of thing. And remember, some of this runtime stuff is happening on a mobile device, right? Online layers in mobile map scenes and packages. The whole idea about making a map package is that you can go out in the field and be disconnected. But what they're doing is also allowing you to, to build these mobile map packages so you can mix local only data with online data. So maybe you have some sensitive data, or maybe there's some licensing restrictions on how you publish certain data. So as put local on the device, but then you can still pull other stuff. If you're going to pull other stuff live, you are going to need, a cellular or type of Wi-Fi connection when you're out in the field. Dynamic rendering using the GPU, it's pretty pretty important to have like a smooth interface that as the symbols are rendered, they're done quickly. And instead of getting the CPU to do all that work on the main thread or interrupting your application, is if you can offload it to the graphics processing unit, go for it, right? And so they're doing a little bit of that now. When you do identify now on raster cells, you can get the values back in that. And better support for pop-ups. So there's a lot of stuff you can do in Arc Pro now before you publish a map online. You can configure the pop-ups and customize them and that. And the idea is that if you've done that in Arc Pro and publish it in ArcGIS Online, then when your mobile device goes to that map, which has the embedded pop-ups for each layer, that instead of you rebuilding those pop-ups in code on the device, you say, hey, look, the map has its own pop-up. Just use the map or the layers pop-up that's in the map or map view. A better routing in navigation, just upgrade it to match, to have a standard across the whole platform. Better support for locator files. Locator files are just different ways of geocoding. You type in some text and that produces a lat long that zooms the map. Actually, I'm going to back up here for a sec. Let's go, because we'll go into their blog post, because they got some good eye candy in here and that sort of thing. So there's a really good description of the utility downstream tracing in that to isolate something if you have, I think in this case it's a gas leak and that sort of thing. Or you can do this, I guess, do a parallel concept for electrical networks if there's an outage as well. Okay, image overlays. So to have these images overlaid on your map and to have it, I guess, smooth, right? That's the idea. A lot of this stuff is to do it smoothly in that over the image. Because again, these runtimes could be on mobile devices. And so it's one thing to do on a desktop where you typically have more resources, harder to do on a mobile device in that. This is the on layers. So online layers plus local layers mixed for map packages and scene packages, right? The symbology rendering on the GPU. You got to watch these for a little bit. But what you'll notice that on the dynamic, as you zoom in, it's pretty smooth about the images getting bigger. What you'll notice on the static is there's a bit of a chunk, just kind of a chunk, and then the map rejaws, right, with the new size symbology and that sort of thing. And so this is like you doing a pinch zoom on your device. It just have a much smoother display of symbols. Again, they identify pop-ups, identify for raster cell values, and better support for pop-ups, routing navigation, and that. And one thing about upgrading it is these performance gains, right? Because how fast things happen on the mobile device, your application can seem laggy, right? Or that it's the term on Android is janking, right? That feels like it's slowing down or lagging, right? And there's a few other platform-specific improvements, moving to Metal for rendering on the iOS, and that as well. But get in here and read this article. It's got some good stuff in there. And they're always adding more stuff, and there'll be more stuff in 9 when that rolls out in the summer. So what we're going to do is switch gears, okay, off of runtimes and design patterns. Because depending what runtime you're in, you can be in a different design pattern. And so there can be some frustration. Why are things the way they are, right? And the way things are organized. And some platforms, they evolve over time. So they support multiple design patterns. But we're going to talk about a couple. Okay. We're going to start model and view, right? We'll call it MV, right? And that sort of thing. What it means is we're doing everything in one file. We're speccing out the interface, and we're also got the code that responds to someone clicking on a button, but it's all just one big mashup in one big file. Really, well, we'll just get into it and that sort of thing. Okay, so what does M stand for? M is for the model. Okay, and that usually means your data. So usually in code, maybe you've created a bunch of classes in that, and maybe you've even gone to disk and loaded the data in, but you load it into these structures in memory. And so you have this data that's sitting in memory structured a certain way. Okay, maybe it's a list of classes. It's a classic thing, right? So you have a list, you have this an array list or some type of list in Python. Yeah, it's just a list in Python. It's an array list in Java. But those lists have several items in them or elements, and then those could be classes, and those classes could have a bunch of properties. So you've structured the data in a certain way, but that's just in RAM. Right? It's just in RAM and that. And so the model is the data for your app. Maybe it's something as sophisticated as a feature set, right? That where you have things organized in a table with rows, and the rows have column types or data types, and there's a special one for geometry, right? And the overall data set has an SRID associated with it. So it can be really complex structures, right? But what we also know sometimes when you read up on these design patterns, I mean, what they're really talking about is a button, right? They're not talking about something as complicated as a feature class or a feature set in ArcGIS. They're just talking about a button. But I mean, in some frameworks and languages, when you go to the button, they can have 20 properties on them. Am I enabled? What's my font? How big is my font? Right? What color is my font? All this kind of stuff. And what's my text? On and on and on. And so just organizing all of the data for a button can get complicated depending on how bloated the frameworks become over time in that. So it could be just organizing all the stuff about a button, and then all those different events. What happens when someone hovers over it? What happens when someone goes mouse down but doesn't let go of the mouse, right? Selects it but it actually hasn't let go of the mouse. What happens when someone has mouse down on and let go? Typically, what we call like on click or something like that. And that might just have a reference to what function to run. But there's all this data that represents just even a button. Okay. Am I on or off? Am I enabled? All this kind of stuff. So that's what M is. So you got to have to organize all the data in memory in the background into all these different classes or data structures in that. So that's pretty normal and that sort of thing. View, V is for the view. So MV, but the problem with MV is that we're doing everything in one file. So part of my file is about organizing the data, and part of my file also does the interface, right? So V is the view, what the user sees on the screen, right? In that. And so maybe we have data organized in a table, but one way of looking at that is like in Python, bring it into GeoPandas, and we see it as a chart or a series. Or maybe we see it as rows and columns. Or maybe it's got a geometry thing and we see it as a map, right? And that sort of stuff. So we can have this data structured in a certain way. And then the question, well, how do you want to look at that? Okay, because in JS we do this all the time. We typically see it as features on the screen, but if we go over to the contents area, we can right click on that layer and go open attribute table. And now we're not looking at the data as, we're looking at this data more like a database view, rows and columns, and organized that way versus where you are on the ground and that kind of stuff. Right, so one thing we see a lot today is a button slid to the left versus a button being slid to the right, toggle. So a lot of interfaces now, we have these little toggles that for touchscreens where people can take their finger and slide it across, right? But in the day, that was just a checkbox. It's a thing that's on or off, okay, in that. But for touch interfaces, right, what I call the big fat finger, sometimes it's easier to have a bigger looking toggle that a user slides, so they know that they've slid it on or slid it off. Versus a checkbox where they had hit the box just perfect and the little check appears. But basically you're doing the same thing. Is it on? Is it off? It's a different way of viewing it though. Now sometimes there's no separation, right? So in this MV pattern, we have this model, we have this view, but we have it all in one file, like I was saying. Could be hot sticky mess, type of what we call spaghetti code. Where the business logic is, right? And so you may have some rules, like ArcGIS has rules about like domains, right? And subtypes and all that business logic. But it's all, I'm not saying that they do this, but you could design a piece of code in a way that everything's jammed into one place, right? So it's harder to debug. It's harder to test. Like the only way to test it is actually to run the whole application. And when you're doing your test all parts of it. And so if you can make it more granular, and you have the ability to come in and just, is update name working, right? And that update date working. Just a little pieces of the interface and just test those individual parts to make sure that they're working. Sometimes when it's in this big spaghetti code kind of concept, model and view, it's like all or nothing, right? And it's all going to work or it's not, and you're not even sure if you tested it in a way that tested all possible cases to see if it could fail. Now typically, another thing too is that if you have an application where you're collecting data, whether that's in the field or the user's typing into a text box or something, or they're creating something, they're drawing circles on the screen and rectangles, and like when you draw a diagram, right? The idea is that is the user going to lose all that information so typically we want to be able to persist the data. So if they use a piece of software to create something, like you're using Google Keep to make a checklist, like you're going to go to Costco, go shopping, right? The whole idea is that, well, I made this list, I want it to be saved. And so it has to persist somewhere, whether it's in the cloud, on the local drive, that sort of thing, or it gets shot back into a database. That's another story. But typically you want to be able to store the data for your app somewhere. Maybe it's local, like I said, maybe it's locally on the device in the SQLite database or something like that. And then later on, when you come back to the app, you want to be able to pull that data back, right? And restore it, right? And maybe you don't do that, right? I've had some apps where you mess around, but you can't save what you're doing. Oh, I really like what I did there. There's no way to save it, right? That kind of stuff, and that sort of thing. So it all depends, right? So where we usually start out, unfortunately, is here. Right? When you first start out, you're just trying to get stuff to work, right? So and I've done this in my 7010 course when we're doing tkinter and doing examples of tkinter. A lot of the stuff is in one file. So the code that defines a button is in the same file as the function that responds to someone clicking on the button. So the only way to test that is to fire up the whole application, right? You can't do what's called unit testing, test smaller parts of it, and make sure that that at least, you know, when someone types text into the text box called last name, the last name actually gets saved back in memory, and it actually gets saved out to disk, and we can exit the app, come back into the app, and reload that file. Hey, and whatever the user typed in is now there. Okay, that sort of thing. So, but it all depends, right? And that sometimes you just code like crazy, and then you don't think about the structure part, and then oh darn, we're going to be able to save all this, and it gets really messy on trying to save and restore your application in that. So this can result in a lot of pain, right? If you don't think about these things ahead of time. So I just want to talk more about models just so that we get a good grounding in, okay, we're surrounded by models all day long, right? We just might take it for granted. That's it. So the normal case for JS developers, the data is clearly separated, right? So for us, like we might like skip over this because we're so used to it, right? So the data is clearly separated, right? ArcPro is one thing. The file geodatabase is another thing. If I'm using a file geodatabase off in a folder and I package up my ArcPro project, that data could go missing, right? So we understand that there's two different things. Data, me viewing the data, right? So we're very aware of where the data is coming from usually. Oh, that's a shapefile. Okay, that's from a file geodatabase. Okay, that's from an enterprise geodatabase. Okay, that's from an online hosted feature service. So because we're the ones who connected to it. So, you know, I know that's where that's coming from. Data model kind of concept. Right, so shapefiles, geopackages, feature service, OGC web feature services, feature sets, feature classes, file geodatabases. These are all different types of data, which would all have different types of models in the end, right? And there might be some universal model, right, that tries to manage it as one type of things to make it easier on the software people, okay? Or maybe we're getting vector tiles for map. There's always new formats popping up. Right, and that was part of that change arc video. Is right, they were due. So what's there's something new coming. We just don't know it yet. Right. Now, even though we have these physical models on disk, like a file geodatabase is a directory, which is much different than an enterprise geodatabase, which is in, you know, SQL Server or Postgres or in Oracle. Right. A feature set is JSON. Right. Geopackages is an SQLite database, right? Shapefiles are their own thing, little triad of SHP, DBF, and SHX. And vector tiles, something completely different again, right, from Mapbox. Right, so those are all different physical storage formats, right? But if we're going to work with it in code, we still have to load that off of disk and put it into a structure in memory. Okay, so we still need a model on the software side, and then that's up to the developer, yourself. How do they want to load it, right? Well, I'm going to mimic the concept of a georelational table using a Python list, right? A Python list of lists, or maybe I want to use a list of Python dictionaries, or a Python dictionary of dictionaries, right? All that kind of stuff. So there's got to be some type of thing that we do in code in memory to store that physical data, get it off of disk, and put it into a model in memory, right? Now, part of what ESRI tried to do with when they first released version 8, which had ArcMap, ArcScene, and that sort of stuff, is introduced the geodatabase application logic concept. So the geodatabase provides application logic, so separation of the physical reality. So it doesn't matter if it's a shapefile on disk, or a feature class in a file geodatabase, or a feature class in a personal geodatabase, or a feature class in a runtime geodatabase, which would be SQLite as well, or a hosted feature service, or a feature set. Doesn't matter, like, those are all different physical formats. When it comes into the system, at some point, right, as it comes in, right, it's just called a feature layer. Done. right? And so we abstract that physical reality into this software thing called a feature layer. And we can go to a feature layer and find out its SRID. And we can go to the feature layer and find out its fields. And we can go to the feature layer to see if those fields have any domains. Maybe they don't, right? And we can go to the feature layer and get the feature class out and then get a row, right? And eventually go to a row and pull out the shape field and get the geometry in that. And just so we have a standard software way of describing all these different physical formats. So they all, as they come in, get translated into this software version of some spatial data. In the SDK Esri world, right? Probably a feature class, but if you're seeing it on the screen, then we move up to feature layer because it's a feature class plus symbology. You may have heard about the georelational model. So the georelational model in a relational database management system, we see the features, like I said, as rows and columns in that, but we can take that same data and stuff it into a georelational model, but put it in JSON, and it becomes a very, when you look at the physical implementation, a very nested structure, right? Whereas the relational database management system version, or object relational database management system, will be a two-dimensional table, rows, columns, right? But georelational model in JSON, different beast. But in software, we still need some generic abstract view of the data so that the software people don't have to completely rework all their code depending on the physical format, right? So do I want to have this generic abstract thing called a feature layer feature class, or do I want to create individual ones for each of these physical formats, right? A separate one for shapefiles, for GeoPackage, feature services, GeoJSON, right? JSON feature set, feature class, and have something different and have to maintain all that code as it changes over time? Or do I just take those formats, flip them into my software model of what I believe spatial data should be? So view examples, right? The normal case for JS developers. So that's model. We've seen data all the time. We've heard of feature classes and feature layers. We've seen that in the geoprocessing tools. But what about the view part? So the normal case for JS developers, we grew up in this georelational model. It's always been there. So we could be taking it for granted and not realizing that we're switching views on stuff, right? The map is omnipresent. That's one view of that data. So that's one way of looking at that, the feature set, or what we call a feature class or feature layer, is look at it as a map, okay, in that. So you're in code, especially in the JavaScript API and that, and anyone, to get the map to move or something, you're usually trying to hunt the map down, or maybe you have to hunt down the map view to get it to move. But you're always trying to hook into it because that's where the layers are, and so layers mean data, right? So it's quite normal that we try to find this map and then try to find the layers and then get to the data, right? But that's not the only way we work with the data. So we can go data as a map, data as a chart, which we'll see in dashboards, data as a gauge, data as a table, right? So we've all done this, whether we're in ArcMap or even QGIS and ArcPro. When you go over to the contents area, you have some dots up on the screen. You can right click and go open attribute table or attribute table, and then you get a different view of the data. This is the view as rows and columns. And the map is the view as spatial features relative to other spatial features, right? And so we may not be realizing what's going on here, right? There's a video coming up that I want you to watch, and it's going to demo some dashboard stuff. But basically, dashboards go to a map to get what they call an operational layer, which would be, a feature layer, but it comes across on the web as a feature set, as I mentioned in the change arc in JS. And then that's when it gets some rows and columns, and they can use those rows and columns to make a list. You can use those rows and columns to count something up and have a gauge, right, to tell you what the count is. Or it can use some of the columns in that layer to make a chart. And that's just a different view of the same data, right? So we have this chunk of data. How do you want to see it? As a map? As a chart? as a gauge, as a table, right? On and on and on, right? Also, Insights is a tool where ESRI, when you're working with hosted feature services or I guess assets you have in ArcGIS Online, maps, because maps have layers, you'll see the same thing in that video that I want you to watch, in that you'll see it flipping from a chart to a table to a map. So what you can do now is pause my lecture video and watch this one on Insights. And so you'll see these card systems, and you can say, well, you know, typically you find a map, you pull a layer out, and then you say, well, how do you want to see that? Do you want to see it as a map? Do you want to see it as a heat map? Do you want to see it as a card, as a graph, and that sort of thing? What you can do now, this is another video that shows the operational dashboards. This is all stuff you can build in ArcGIS Online, so you can play around if you want with your ArcGIS Online accounts. You can make dashboards in that, but the key to dashboards is you already got to have some data published in ArcGIS Online, typically as a map. And then dashboards, their controls typically go in, find a map, find a layer in the map, and then hook their control into that data stream in that. So I'm going to switch gears here and talk about Model View Controller. We talked about Model View, and then we talked about, look, we've got all these different views on data, right? It's not a new thing in that. And so we're going to look at a pretty standard design pattern you see a lot in desktops, MVC. So what's new? Before we had MV, Model View, right? And what it was is that file that had both the model and the view, probably in there was the code that controlled the interaction between the two. But we separate them out, right? There's a controller, right? So it gets into this concept of separation of concerns. The view does the rendering part. It takes care of what the user, probably also the view captures a little bit of, hey, a user clicked on this button. What do you want to do about it, right? And that. And so there's a separation of concerns, right? The controller typically takes care of processing events. So the view will say, hey, someone clicked here. Then the controller will say, well, what do I want to do about that, right? So they clicked on this button. And that might cause the controller to update a field or make all the values in a column go uppercase or something, right? The controller will go do that. Or there could be some other business logic, like, you know, the user typed in this value, is it in the domain value for this particular column? And that. And so this is separation of concerns, that view does view stuff, model does model stuff, and the controller is that, you know, kind of, well, controls the whole operation. That's the concept, right? But there is a thick controller problem, and people who use the MVC pattern on Android for their activities. Apps on Android are a collection of activities, and sometimes they're just one activity. But what happens is there's a lot of code gets into the controller, and the controller grows and grows and grows and grows in the number of lines. And as it grows, it becomes very hard, right, to fix something, because sometimes when you try to change one line, you break something downstream from that and that. And so it can take a very long time to debug. Okay. And so I don't know if you can ever get away with this, get away from it, unless you have a bunch of smaller controllers and that sort of thing. But what tends to happen, right, is that this controller grows pretty big, and is, you know, as with anything, is trying to do too much, right? So have I seen a controller before? Yes, I have. So when I did my 7010 course in JavaFX, and that, which in JavaFX can be desktop and mobile. The one thing to know about mobile devices, they are closer to a desktop device than a web page. So like when you're working with mobile apps, although they might hit online sites to get data, the way they interact in terms of clicks and people tapping and that sort of thing is very much like a desktop application. You're building like a little desktop application for a small screen and that. And so a lot of early mobile apps use this MVC pattern, Model View Controller, right? The one thing about MVC, it's way better than MV or spaghetti code, right? At least there's some separation, right? And so I mean, the complaint would be that the controller gets pretty thick, it grows over time, it gets bloated. So maybe, maybe you just need a way of chopping the controller up into different chunks in that. And so when I was teaching 7010 in Java, right, we'd have a little wrapper class called main stage that would launch the whole application. We'd actually have a controller class called the main stage controller, and then we'd also have back up in here a main stage fxml. So the main stage just launched everything, but the user interface was in a separate file, separation of concerns. It was even a different language. fxml is a XML language, and then their controller, the XML file would know who its controller was, because there would be a line in this text file that says, oh, by the way, my controller is over here, right, and that sort of thing. And the way it works is a view can have one controller, but a controller might be used for multiple views and that sort of thing. And we'll get into that shortly. But because of that last part I just said, a controller can be responsible for many views. That's why it can get big and that sort of thing, right? So where is the model in all this? Well, I'll say where's your data and that sort of thing. So maybe your data is in a database and you connected to it, and then you brought the data over, and then you took all the data from the table and put it into an array list, is what they would use in Java, of POJOs, plain old Java objects, right? And then there's a way of tying the data for one of those objects in that list to the view, and that kind of concept. And that list example isn't too far off. There are tons of applications still out there, and especially early Android, not so much games, but other apps where what you really do is scrolling through a list, like email apps. You're really scrolling through a list of emails, and you tap on one, and then you get the details of it, right? So that list interface of object data, where that object is an email from someone to you, that sort of thing, with a subject and a body and stuff like that, right? That's the model. And so where's the model? It's really going to depend on how did you bring the data into the system, and what did you design, right, in terms of a data structure. Or if you're using like one of the runtimes or the SDK, it's what did Esri design? It comes into my program as this thing called a feature set, right? And then I try to hook that up to the view using the controller. Binding is an interesting thing, okay? Not always done, right? So it depends in that. So are the controls on the view bound to the properties of a model? So you have a model. The models usually are plain objects with what are called, properties, have getters and setters. So when someone changes something in the view, that'll eventually have a setter called, right, which will change the data in your model. And there might be something else working with your model that ran a setter, and then you have to be notified that something's changed. So if something changes in the model, will that value eventually show up on your app that something has changed? Okay, but that gets into binding and how, in the language, more of the framework that you're using in a particular language, how is the binding done? Is the binding done? Is it done at all? It's not done, right? Or is it one way? Is it two way? One way would be that if you change something in the view, that changes something eventually via the controller in the model. But what if something changes in the model? Does that automatically get shot up into the view, right? And that sort of thing. This is a problem that's been around forever on desktop systems and has not gone away, right? We keep reinventing how we want to do binding and trying to get better ways to do it, right? But it's always been an issue. Right? So let's take a look at a diagram that might help out. Okay. Oh, and on another note, before we get to the diagram, sometimes it's called binding, but sometimes you'll see observables, like an observable list. I've seen that lots of time on the Java and the Android side. So you have stuff in the list, and the list is observable for someone changing the selection, or possibly for something in that, or an item being changed in the list. So you may not see the word binding you might see this other thing called observables. But what we're talking about is kind of the same concept, that if the data changes, what do we want to do about that? And then we get into whether it's one way or two way. So what I have is a diagram of MVC in that. And so how's it work? So typically you have some data in a model, okay? And then how some systems like to do it, they like to bind the view to the model, okay? So whatever's in the model shows up automatically in the view, right? So if you have a model that stores like student information, their A00 ID, their first name, their last name, whether they're part-time or full-time or online student and something like that. If you're dealing with one of those objects in the view, then whatever's down in your data shows up in your view, right? It's bound to it and that kind of stuff. Now the user will see that via the view, and then maybe they decide to click on something or tap on something on the view. Okay, and maybe that causes a change to the data. So they tapped on last name and they typed in a new last name, right? Or what happens more often people don't always go by their first name, right? And so they want that changed in the system. So we tap on that. The user wants to use this as their first name and that sort of thing. And so then what the view does is it sends that change to the controller. Hey, someone clicked on update, and so then you go see, right? So you go, okay, well, what update it? Or maybe you have to check all the fields. Who knows? How your controller does that is up to you. But basically it says, look, last name changed, send that in. And so then the controller goes in and makes the changes into the model. And then because of binding, then we see that change happen. Now we may not be able to visually see it because the name we just typed in is the name that comes back, but you want that to be in sync. You don't ever get a situation where you're putting stuff in the view but it's not actually making it back into the model. So you think you're making changes but it's not happening. Okay, and again, it all depends where this model is and that sort of thing, and how those updates eventually get done. Sometimes in the view you can make a whole bunch of changes, and there's one button called update, and there's little flags that say, oh, someone made a change to this row, and then the controller's got to go through and process all the rows and send them all the way back into the model, which sends them all the way back into the database and that kind of stuff. So it all depends, like I said, like what framework you're using, what OS you're on, and in that, and then really where's your data coming from, because that can really radically change what happens, right? Is it going to a website? Are you connecting directly to a database and making the changes there? Are you writing to an XML file on disk or some other type of file on disk or some SQLite database that's local, right? But that's what the big thing here is, that a view is typically bound to the model. If changes are made to the model, the view sees that, and then therefore the user sees it, and then the user can decide to do something about that or not. Another big thing is that there's one controller, but we could have many views going to this one controller. So then this controller, this is where you can get the thick controller, where it grows and grows over time. And this is what happens to a lot of Android activities, is they get bigger and bigger and bigger and bigger. And they're trying to typically do too much. And there's all this code that just keeps building up in the controller, especially if this saving this data back in the system gets kind of complicated. But that's the generic pattern. So this is before we had anything, right? We just had one big nasty file, but now we've separated the view out into its own thing. Sometimes it's in a separate file, separate language, and then the controller is in another file, another language. The view usually stamps, oh, by the way, this is my controller, so that when someone clicks on a button in the view, then it knows to call the controller and say this happened, and the controller does something, and maybe that changes the model, and then you'll see those changes. So a lot of applications were worked out on the desktop first, right? Because why the desktop first? Because the web didn't exist and mobile didn't exist, right? So first we had desktop. Well, first we had mainframe, then we had desktop. then we had web, then we had mobile. So the thing is, this pattern grew up in the desktop world. So the developers, right, when the internet hits, and right, the only design pattern, I won't say only, but the dominant design pattern, if you're even using one, right, was model view controller. So what they did is just migrated that to a web version of model view controller and that sort of thing. That's just how it happened because it was the only thing around at the time, right? So early model view controller over the web, right? The way it usually works is a lot of page refreshes. So the view sits up in the browser, right? And then the user makes some changes and they hit the submit button. That's how a lot of times it used to be. And that goes all the way back to the server, and then the server recreates the page and sends a new view back to the browser, typically, right? In that. So if you think map server with its map file HTML template, it typically is. If you ever look up the life cycle of an ASP page, right, even that's ASPX.NET, there's a lot of these full page refreshes, not a very snappy interface. There's usually a little bit of sometimes you can see the page loading on a refresh, but definitely some what we call, lag or janking, right? Even some modern web frameworks still use model view controller concept. Okay, the Django has it, right? Rails has it. It doesn't mean they don't have other ways of doing it, but it's still there. ASP.NET had it for a while as well. So if the HTML client is uber thin, there's hardly anything in it, slightly passive, or not too smart, this doesn't do too much, then you're going to have a super thick, we'll call it microview controller server on the other side, but basically the dominant controller part, where it's figuring out this is what the person said on the web interface, and that kind of thing, recreate the page and send them a new page, and the controller doing that. And it could be the controller logging in to a database and pulling out data and making a new page and that. So what about Java server pages or PHP and ASP? Basically the same, right? If they even got to this stage, right? The way some people use this, because this is a design pattern. You don't have to follow it. So some of the early Java server pages, PHP pages, and ASP pages were actually just model view. Or actually, if I was honest and truthful, spaghetti code, right? And that kind of stuff. So you can do it, but then this is where we start to get a little bit of the grinding of the gears that, okay, this is not as snappy as I need it to be. It's also a little harder to test too. I mean, to test this, you would still have to, especially because it's a web page, get a human to go to a website and click on stuff, and that's a little harder to test or do what's called unit testing in this environment. And so now we're going to talk about MVP. So MVP isn't its own thing. It's an evolution of MVC, right? So the people said, well, can we do this a little bit differently? Because this is killing me in that. And so people just think, well, what if we designed it a slightly different way, right? So what's new? The presenter, right? Monkey in the middle, basically. But basically, one is that when you look at presenter, you're going to go, that just looks like the controller with a different name. And I'm not going to argue that part, but you need to rename it so that people understand, right? We couldn't call it controller because then our acronym would be MVC, just like the last one. So they changed the name of the controller, but it's basically doing a similar process, we'll say, but there are some subtleties now that really change the game. Okay, and the big difference is that the model does not directly update the view, because in the web environment, your model could be sitting in RAM back on the server, and maybe you're running ASP.NET and it's in C#, or maybe you're doing Java server pages and of course it's in Java, or maybe you're PHP, so it's in PHP. But up on the web front end, it's going to be either JSON and HTML, right? Completely different languages in that. And so the view, and this is nothing too, the view is very far away, right? It could be across the internet in another country in that. So it's loaded up in someone's browser. And your server's back in the Amazon cloud somewhere. And so that's another thing too, is that the MVC pattern that we talked about previously usually means that the data is pretty close to where the view is. And so on the desktop, your file geodatabase is really close to Arc Pro, right? They're on the same machine. And so when you're on a mobile device, this happens too. Your mobile device, the interface, is really close to the data, because sometimes the data is an SQLite database on your mobile device. So they're actually on the same box. But definitely when we're talking about web pages, we have a browser on someone's mobile phone halfway across the world, or on their tablet or on their desktop, talking to some server that could be like in another country. So we definitely have some separation between the view and the model, right? And so trying to bind directly to that with network latency is going to be kind of weird and slow. So the model does not directly update the view. So and this will become clear when we get to the diagram. So the model is way over on the left, we'll say, and your view is way over on the right. And there's a bunch of stuff in the middle, right? So we have complete separation of the view from the data. So our separation of concerns, right? Not only are we on different machines and different languages typically, and that. So clear separation, right? But then everything has got to go through the presenter. Before, the view had the ability to bind directly to the model. So if the model changed, then the update, then the view, if they're doing binding, right? Not everyone does. Then the update to the view would happen automatically. Because now everything's separated, then everything's ran through the presenter. So the view requests change, the presenter goes to the model changes, the model comes back to the presenter. The model doesn't even know who the view is. No clue, right? Whereas before it could be bound directly so they knew of each other and that sort of thing. And then the presenter forwards those changes back up into the browser and that sort of thing. Now you can't, it doesn't mean that because you do MVP that it has to be a web application. Okay, it's just a design pattern, but this is where it grew up and where it got popular. Now the presenter could be server side or client side or maybe both, right? That kind of stuff in that. But there is this piece in the middle that used to be called a controller, but the view has completely been what's decoupled from the model. They're completely separated now. And so the model has no idea who the view is, whereas before they were bound together. And the presenter has to do all the work in between. Get all the things that have changed from the view, send them to the model. The model comes back with, hey, maybe that didn't work, who knows. And then the presenter will update the view. So what do you get, right? Like I said, clear separation of the model from the view, right? And that almost has to be the case if we're talking a web scenario where, like I said, the view can be halfway across the globe compared to where the data is back in the model. So what is the trick, right? You either do what are called events, or in some languages they're called signals, and there's lots of callbacks, right? And so the idea is that the view typically goes to presenter makes the AJAX callback on the client side back into the back end where the servers are. And then whenever the data is processed, and you do this in an asynchronous way typically so that you free up the interface. And so whenever the data comes back from the back end via the model, it ends up at the presenter. The presenter says, what did the view tell me to call them back on? Oh, run this function in the browser. Okay, that function goes to a little chunk of the overall page and changes a portion of that on the fly. So there's lots of callbacks in that happening. And when we get into JavaScript and callbacks, then we also get into things called promises. And now there's another new technique, async wait and stuff like that in JavaScript. So they've been trying to solve this problem, and they've had multiple generations in terms of software to take different approaches to how we do this callback scenario. But we'll take a look at a diagram in that and just go over some of the changes. Now again, have the people implemented MVP, the MVP pattern, right, in this particular way. Right. But the idea is that the view, and they say it's more passive, so it doesn't do too much, right? It's basically whatever the presenter tells it to do and that sort of thing. But the user interacts with the view. I mean, the view is what the user sees. So maybe this is your mobile device and you're looking at a page in a browser or something, right? Or let's probably take a desktop scenario. You're using a web application and it's going to, maybe it's Fitbit and they're calling back into their data center to get all your stats, how many steps you had that day, your heart rate, and all that kind of stuff. But these are the widgets that you see on your screen, right? But this view is called a passive view because basically when it makes a call in and the presenter comes back, then the presenter is going to change a bunch of stuff inside. So this is you way out here, and then maybe across the internet in another country, right? And that is the model. This part over here. Now, part of what they do is to, why people like MVP is that there's something called a view interface. And this is more code land, right? But what it means is that you can swap out. And here's a swap out point. So this is a human messing with your view. But I can swap out and maybe do some unit testing where I have the computer test the view interface, right? And so this is an advantage of MVP is what's called unit testing. Now, if you're a small shop making a solution for your boss that you got to kick out by 3:30, then you don't want to get involved in this. But people like Esri who build web applications and need to test that the code they're adding to Web App Builder and Experience Builder isn't blowing stuff up, they need a way to better test their code or systematically test their code before they get to the level of testing with humans. So what you want to do is, can we test the code as much as we can with the computer to make sure things are working, so that when we put it into the human hands, we're not catching bugs that we could have sort of caught with automatic testing and unit testing. And so what happens is, because you have this view interface, this is where you can swap in your testing view, right? Which is just automated testing based on code or some unit testing kind of system. Like on Java side, they have something called JUnit that basically does this. But it does mean that in the software land, you have this abstract view interface and you implement this interface, but this is the real view that the human sees. And then my testing, unit testing harness or system can lock into this view interface and act like, hey, this is a user clicking on a button, but it was a computer clicking on the button kind of concept. So this is one of the advantages of MVP, if it's designed this way, is that there is this view interface, sort of abstract thing that you can connect one view at a time. There is this one-to-one relationship in that the presenter is hooked to this view interface, and it can only do what this view interface says. And so maybe this view interface has things like get name, set name, get ID, set ID, get age, set age. But then that's kind of locked down. Before we had a thing where on MVC where the controller could talk to many views. Here it's a one-to-one because we have this view interface, right? Everything is a trade-off in life. And so the trade-off is, well, I can hook different views to this view interface and do human testing versus automated testing. And so this works better for unit testing and making sure something like Esri might want to, test is like docking panes and stuff like that, separate from actually building up an application and stuff, or different things, talking or making changes to a geodatabase and get the computer to test a bunch of changes to see if it's done, right? And so then you have this presenter controller in the middle, and then you have your model in a layer away from that. But the way it is, how does it work? So the user sees something, and they say, oh, I need to change that. So they make a change, click a button, right? Now this view then calls into the presenter and it makes those changes, and then those changes get put into the model. And then the model communicates back, hey, changes got made, and tells the presenter, yeah, they got made. And then the presenter goes, who was I talking to? Oh yeah, that view. And then sends those changes back up to the view, and then the user sees the result of that change, let's say. So the idea is to really break the connection of the view to the model, right? The model has no idea who the view is. It only knows the presenter. And the presenter actually doesn't know who the view is. It just really knows the view interface, right? So the presenter doesn't know if it's talking to a human or a computer or a unit test. It doesn't know, and that's a good idea. And so if you're building bigger applications and for the long run where you're going to be adding features and maintenance and making changes, then this can really help. The changes that we're proposing, does it break anything? And if they pass all your testing, then you can release a new version out to the wild, to the end users. So here's some caveats. I've hinted towards this. What makes something MVC and MVP, right? Not the language. So if someone tries to say, well, Java is MVC or Java is, no, that's not what makes that decision, right? Right? It's not that something is Java, JavaFX, JavaScript, Swift, Ruby, or Python that makes it model view controller or model view presenter, right? Typically what I've noticed, it's the framework that makes that determination, whether it's Dojo, right? Ruby on Rails, so it's really a Rails issue, right? And that kind of stuff. Springs and struts in Java, right? So although Java is the language, Springs and struts is the framework, right? Or struts, I should say. So it really depends on what framework you are using, whether you're MVC and MVP. And one thing might be that you have no choice, right? So for you, it's going to be whatever you've been dropped into, right? So if you've dropped into the ArcPro SDK, then you've dropped into the MVVM world, okay? In that. Now, sometimes frameworks and languages get grouped together. Ruby on Rails, like I said before, and that. If I go struts, then everyone knows I'm talking Java, but what I'm really talking about is how the struts framework works in that. So there's lots of different frameworks. There's multiple frameworks per language. Okay, Django is a framework. Flask is a web developer framework. Node.js, there's lots. We can go on and on in that. Right. So the thing is, frameworks and languages, they are not the same thing. Okay, so because someone could take a framework in one language and basically build the exact same framework, but build it for Java, build it for PHP, right? Build it for Swift, that kind of stuff. And what we're talking about here are these patterns that could be applied to any language. You just have to put the pieces in place, the concepts of a view, the concepts, if you're going to do MVP, of a view interface, of a presenter, of a model. I'm going to talk a little bit about MVD. It's a special one in that, so we'll just jump in here. So what's new with MVD? This is a Qt thing. So if you work with the runtimes and you run into the Qt runtime, whether that's directly with Qt or with App Studio, then you yourself are going to be put into this MVD, model view delegate construct. Okay, lots of rants here. What's the difference? All that kind of thing. You merge the view and the controller, right? Which is going to sound like this new thing we're going to talk about soon, the view model. You merge that, but then you introduce a delegate, the ability to switch out a view. Sounds weird, right? But that allows you to do the testing, right? And that, right? So delegates can be swapped out on the fly, not just for testing, but they can actually be swapped out as the thing is running. So one thing that Esri has done with App Studio is they have the App Studio Player, which can take any solution, any app that you build in App Studio and just run it through the player. So basically the player is swapping out on the fly the whole app in that. So you don't need to have something in the Apple Store or the Google Play Store for someone to download and install. You first install the App Studio Player, and then it can just load your app right into. So that is that is a big swap of swapping out the whole application that is running inside the player via delegation. right? It definitely helps for unit testing, right? Testing without the human, and that MVP has that advantage as well, right? Its communication is via signals and slots. These are event and event handlers, right? They just use different terminology when you're in the Qt world, right? There's some signal. They do a lot of embedded systems, right? So some switch, some signal from the gas tank says you're low, right? In that, right? And then the event handler says, okay, turn the light on the dash. Now, this, where we get into this, we can have a little techno-weenie debate. Is MVD and MVVM close to the same thing? There's one way to look at it and say, no, one's from Qt, one's from Microsoft. They do it totally differently. Or you can take the 30,000 foot view and say, look, some of the stuff, the swapping of the delegate is like the swapping of the view, and the merging of the view controller is like the model view and stuff like that. But like I said, I don't like to get into techno-weenie debates in that. But some of the side effects of MVD and MVVM are very similar, and they allow for certain things for you as a developer. And this is, again, for bigger apps that need to be maintained over time, to hunt down bugs and test, as you introduce new features, to test your code to see that it doesn't break something else. So the model informs the view about changes to the data source in that, right? The view captures users' interactions. User clicked here, right? Or swiped there, right? Signals from the delegate inform the model, right? And the view in that. About the state of the, as they say, the editor, you making changes. Okay. What we'll do now is we'll talk about MVVM. Because this is the pattern that if you work with the SDK, you will be, I guess, forced to get used to. You're not going to have too much of a choice. Right? So we can say it's an evolution of MVC, MVP to MVVM. Okay? And this pattern, it did start out at Microsoft and .NET, but other people have adopted this pattern in other languages and frameworks. Right? So it's the decoupling of the view and the presenter, which also happens in MVP a little bit, right? The thing in Java FX, FXML, the XML file knows exactly who the controller is in that. An example we've seen in a previous lecture was the config XML for the ArcMap add-ins. So in that XML file, they make reference to the actual Python file, right? So it knows what Python file has all of the code, right? So an add-in structure in ArcMap, right? That portion of it, where the config XML, right, which has information about the view, in that kind of does a model view controller aspect at that level to tie into the Python file in the install directory. Now, one side effect, or almost side effect, is this decoupling. This is where people have used it, and we'll talk about this, and this is why it's popular and gaining popularity, because we sort of have that ability of this view model, and we can hook views onto it at different points in time. Much like an MVP, we can swap the view out because of the view interface kind of concept. It definitely helps with screen rotations. Okay, on your mobile phone in that. So as you flip your phone, you can end up with a different view. I'll talk about that portrait landscape view. And then what happens? So those right there could be different views in your application. You might be on a tablet. This is something to try in Gmail. Have your tablet in portrait form, flip it to landscape form, and then just sit back and say, is the data, my email, being presented to me in a different way, right? And it might depend on the size of your tablet if you actually see this, but I know that on I got an Asus ZenPad 10. If I'm looking at my mail in portrait orientation, then it's kind of like my phone. But if I flip into landscape, I definitely get a different user interface presented to me, which would be a different view. Another thing that they do on the screen rotations, besides different views, I got a little ahead of myself there, is the saving the state in that. And so having this view model in memory is that we save the state. You may have an old app on your phone, and when you're working with it, if it rotates on you, you lose all your edits, kind of stuff, and you have to retype stuff in that. And so that's probably using an older design pattern. So part of what happens with the view model is everything that you've been typing in through your view gets into the view model, so that if your phone rotates, when it comes back in and binds to a new view, all the data is there. And so it's about saving the state of the application, because one is a legacy issue. There's a video that you can watch later on in Android where the activity on a rotation gets destroyed and recreated, right? So it deletes the interface and makes a new one, but you're like, hey, I was just typing something. And so by having the view model exist in memory, is the new view can tie into that save state, right? It's not really saved, it's just sitting there in memory waiting for you to hook back into it. Definitely another side effect is that ability to swap out views on the fly, whether it's a screen rotation. You can also swap out from human testing to computer testing, right? So definitely it allows for, right, unit testing, which is a big thing for MVP and MVVM, right? So no humans tapping a button or swiping, right? So in MVVM, one can design in a way that would allow one to test the concept of a human swiping, right? That's sort of on single tap, right? On tap and hold, a user pressing down and holding. And so you can test these kind of scenarios without actually having to make an APK, put it in the store, have a person download it, install it, get them to tap on it. Does it work? Right? That's a long debug cycle. So this is a MVVM diagram in that. So you have the user, right? The user sees something on the view. So the user sees something on the view, interacts with it. I want to change that and that. And then the view tells the view model, hey, makes these changes. The view model talks to the model. Model talks back to the view model. This starts to sound like the presenter, but you may notice that the interface is gone. And then it talks to the view, and then the view updates the rendering, and the user sees some change on the screen, that something's happened. Do note this big thing in here that gets into the play of the rotating and lots of other things and the automated testing, is that we can have many views going to one particular view model, right? So we have big separation between the model and the view, right? Many views can tie into the view model. We typically bind these, so changes in the view model are seen in the view. It's up to you whether it's one way, two way, all that kind of stuff. The view model is responsible for getting the changes all the way back into the data in that as well. And so this thing here, interface is gone, but now we can have many views. This allows you to go, hey, what if it's landscape? What if it's portrait? What if it's human? What if it's computer? Right? That little star, many views can tie into this view model. So you can see where they've taken a little bit of the MVC and a little bit of the MVP and kind of put it together to say, okay, this actually for us, when we're dealing with unit testing and when we're dealing with mobile phones rotating and that sort of thing. Like desktops don't have to worry about the screens rotate. Well, my laptop doesn't worry about it too much. Now, there was an error where you could rotate your screen and that sort of stuff, but you just got the screen rotated. The interface did not reorganize. And what you'll notice, like I said, if you do the email test on your laptop, especially with Gmail, you might notice, okay, they actually present a different interface, right, to you. Just to go over that when you flip your phone back in the day kind of scenario. So we have a phone, right, and then we rotate it like that. And like I said, do you lose what you typed in, right? Because that used to be very frustrating, right, and that. So, there might even have been some profanity when you were writing something, if it flipped on you and then you lost it, right? You might be like, right? Or early versions of your mail system put it into draft mode or something like that, and you had to go hunt it down in that. And so that would be a question, did you lose your data? And this gets really into, depends on a lot of things, I guess. One is the underlying, for Android framework and what's called the activity lifecycle. So every app on Android in code speak is called an activity, right? One or many activities. You can have many activities within an app. But it's how those get created and destroyed. And so when you flip your phone, they delete your existing activity and recreate it from the ground up. Okay. And the problem was, well, I was doing something in there, right? And so it all depends. And so sometimes you would lose it. So you got knocked out by that legacy issue in what's called the Android activity lifecycle and how they get created and destroyed on a rotation, right? And if you did not, a couple of things could happen, right? You had a very nice programmer, and it doesn't matter, it doesn't matter if it was MVC or MVP or MVVM, right? If your data comes back magically, you're happy, in all honesty, and that. But what makes it easier for a programmer, right, is this new MVVM sort of structure. It makes it easier on the programmer because they don't have to save out a lot of data, right? But the problem was, as your phone starts to sense it rotating, it'll kick off a signal or raise an event. I'm rotating. And then you, as a programmer, could choose to take all the data that was in the app, save it out to an XML file or to an SQLite database, and then once it stopped rotating, go back and read all that data in. Now I can do that with an MVC, like model view controller program. If I'd use that design pattern, I can still do that. But typically for me to do that, I do have do this thing about, okay, the phone's rotating, take all the data, save it out to disk real quick, which is what happens. Okay, we stop rotating, go grab the data again. So as the activity is being recreated, right, put all the data back into the fields and that kind of stuff. Now the problem would be, there's a couple problems. If it's a couple of fields, it's not a big deal. You're not going to notice it. If it's a lot of data, GIS has a lot of data, then after the rotation, it can take, a little while for the app to come back to life because it's loading all of that data off of disk, right? If it's if you're using MVVM, then the data is just in memory. You just rebind to it real quickly. There's no reloading because you didn't destroy that part of the app. Now, another part that can kind of lead you astray with MVVM, especially on Android, they'll start talking about live data. That's a different issue, right? But it is this thing that your view model still exists in RAM and is alive and is talking to the rest of the system as you rotate and hook back in, kind of concept. So with live data, this solves, I guess, there's another problem. What if as I'm rotating my phone, new data is coming in from the server, right? A new notification, all that kind of stuff, right? And that in the destruction of the activity and recreation of it, that new data coming in doesn't get lost, right? And so because your view model is still alive and kicking in memory, and if new data is coming into the model, it'll just get added and the view model will get updated, and then when your phone stops rotating and then binds back in, it'll bind back into the new data. Voila, nothing gets lost. And so there's a couple of things that are, because of that, of the fact that the view model still sits there in RAM with the data, then this live data part is even more advantageous, that even on a rotation, new data can be coming in and it will be there on the flip. Like I kind of had myself, but we'll just review that. So some of this is due to the activity lifecycle on Android. It's a legacy issue, right? MVC would have to rebuild the activity and reload the data, need to save the data out after rotation is sensed, and then reload the data after the flip. If not, data is lost, right? So you probably have one app that drove you nuts and you uninstalled it, right? Because it couldn't handle that. And so MVVM, many views for one model, right? There can be this concept of a portrait view and a landscape view. So as you flip, it's just a new view tying in, because we can have many views tying into the same view model. In that, the view model is just the data, right? In that, and maybe a little bit of it preloaded. Oh, this is in a list, but how you show that list, that's still view stuff rendering. It's up to you. In that. right? And data stays in memory in the view model, and then it's about your portrait or your landscape view. If we're thinking of the mobile scenario, just rebinding back into that existing view model, and it makes it much faster on a rotation. And like I said, with the live data, if new data is coming in, then the view model can be talking to the network and loading up the model and handling all that kind of stuff. And it's when you show up after the flip, right? Whether you be the portrait or landscape view, you can just bind back into the view model, and there's no need to load it off of disk again. And so data shows up due to binding. Before, we hit in MVC, we like on the desktop, the view bound directly to that. But if you destroy the view, then it's gone, and all this kind of stuff. And this new design pattern with this view model is to keep that in memory and quickly bring back the views and bind them in via data binding. Right? And that's how on today, with some apps, when you flip them, hey, there's no problem. It's like you didn't lose any data and you're able to keep going again. So what you can do is you can pause my video lecture. This is a shorter video that just goes over Model View Presenter and MVVM. So this person's already jumped off the MVC train, and they've been doing Model View Presenter, and they're doing much more in MVVM. He'll mention Xamarin at the end, so that's part of that Windows runtime where you can write apps for Android and iOS that's using the Xamarin technology. And Xamarin uses this model view model architecture. This presentation is a little bit longer. It is Android focused, but it does go over all the design patterns of MVC, MVP, and MVV design patterns and some of the issues that they've seen. So they talk a little bit about spaghetti code. They talk a little bit about how in MVC, the controller, especially in Android, specifically the Android with the activity, because usually with every XML activity, then you have this Java class that kind of supports that activity, and which ends up being the controller, and it gets bigger and bigger and bigger and bigger over time as it tries to do more stuff. Okay, and just looking at the new MVVM design patterns and how that can alleviate some of that stuff in terms of scalability in maintenance and debugging and adding new features. Right, because the idea is as you add new features, you don't want to blow up existing code. So I just talk about the UI a little bit in that, just to give you other examples along the way. So this is the Java UI, and right. So the interface can be designed with code. However, in FXML, the interface is designed in a completely different language, XML. Right, with a lot of annotations and what are called a lot of FXIDs, right? So it's a specific XML language for JavaFX. Clear separation of the view from the model, right? The model is usually done in Java POJOs, plain JavaScript, Java objects, in that. But then the user interface, the buttons, the lists, are all spec'd out in XML. Nothing like clear separation than doing something in different languages. So we try to separate the view and the model, right? In that. There is a controller, right? And the controller is written in Java. Total number of languages, 2. You got the FXML language and the Java language. Okay? And so this is what the view, the XML looks like. So you see stuff like it's inside a border pane. There's a menu bar here. Right, and the menu bar has a bunch of menu items on it, in that. And on this line, if you could follow this line to the end, you'll see that the controller class gets mentioned. And so in here, this view knows who its controller is. So this is MVC pattern, so that the view is bound to its controller, so it understands who its controller is, and it's mentioned right on this line at the towards the end. Okay, but this is what the Java code looks like, different language, curly braces, all that kind of stuff. So 2 different languages, and besides having an XML version of the border pane, we have a code version of a border pane. So let's go back, right? Here's your border pane in XML with little angle brackets and FID tags. By the name, my name is border pane. One thing is this name has to match this name here. That's how they get hooked up and later. But it's two different languages. The controller is in Java. The view is in XML. And this is my main stage that basically this is the thing that fires it off. It goes and loads the fxml file. The fxml file knows who its controller is and knows who to talk to. And again, this is another Java file or class. And so this is the classic HTML5, no front-end framework, so we're not doing any kind of, Angular JS or anything like that. Right? So the interface is not designed with code, right? Some combination of HTML, maybe it's Jade templating, which has gone to Pug now, and that, or cascading style sheets. The controller, typically some JavaScript function responding to an on-click event, we'll say. Complex could be some AJAX request call, asynchronous call back into a server. And when the data comes back, on a callback function, it updates the interface, right? So hooked to a callback. Callback checks the response status. If the response, like it was good, a 3 or a 4, I think the code is, away we go. So total of number of languages could be 3 or 4, right? And maybe 3 functions to do. So this is HTML. It looks a little bit like XML, but it's HTML here. And that this is a standard form. And that input tags for username and password and those types of things. And that got your head and body tags, but this is HTML specking out this interface here, right? So this HTML makes this interface. So this is not like programming code like Java or Python or C#. This is a completely different thing, right? This is the same thing in Jade, but still it is specking out the interface, right? This is the cascading style sheet, yet another language. And this is the code, this JavaScript code running in Node.js, right? And so this is the code that responds to someone submitting the form. So if we go back a little bit. So when someone clicks connect, right? Do we have the route? Can't quite see the route on here in this mess, in that. But when someone clicks connect, actually, routes here. Routes here on the main route with a post method, right? Node.js knows to go down into its JavaScript, right? And run this part change method sort of idea. But this is actually a callback in JavaScript that's going to do an asynchronous call. So you see all these different mixes of language, cascading style sheets, HTML, some Jade stuff, which is kind of weird. And then this JavaScript. Luckily, if you're in Node, you got JavaScript on the front end up in the browser, you got JavaScript in the back end. Right? Now the Android UI. What I'm really trying to drill here is that we do live in this world where we kind of do separate out the interface design in these different languages. So we have pretty good separation of concerns on this is the view, right? And then this is the controller. And then the model stuff, it all depends. And then how those interplay will depend on the framework that you are probably forced into. Because if, like I said, if you're doing Arc Pro stuff, you're going to be forced into MVVM. So in Android, the interface is not designed in code. The interface and portions are stated in XML file. What you notice is XML pretty standard way of describing interfaces today in that. So in an Android project, there's a directory called layouts. Inside there, you'll find a bunch of XML files that describe your activities or fragments of your activities, right? And that. So partial XML frags, I call them. And that make up the interface, right? The controllers is written in Java, right? And so there's a weird sync between the XML activity name and the Java class in that. So definitely 2 languages, just so you know. If you mix in any cascading style sheet, which you usually don't in that. But you never know what's coming in the future. But you're definitely in two different languages, right? So a lot of XML, a lot of Java, and a thing called R, a class called R. So this is like Android XML to spec out an interface. Text views where you display some text in that. And then there's a whole bunch of stuff about how these things get laid out and who's hooked to who. Inside this XML version, hey, main activity. So this view knows who its controller is and that sort of stuff. This is the Java code. This is this R class that kind of keeps track of everything that you've named in XML, so you can tie to it in code really quick. And that. So this is the main activity, right? And this, if you want to talk to the text view that's on the interface, you got to hook into it and that sort of thing. And so there's this jumping between languages, quite common, right? But it shows you how you can separate view from controller and view from model, because often the model is done in the similar language to the controller. So you in Python, right, you could design the UI with code. You can also design it with Qt Designer, the .ui files in that. Then use Python to load the file, right? So load some designer file. These are, again, XML files, and they can get loaded in, much like we saw with the Java XML. Even Android has a thing where it inflates the XML. It's called an inflator on Android, right? Open it up, load it, right? And then use Python to connect to the controls. And so then Python becomes the language of the controller, right? Design the interface in XML, usually a few lines to load it in and hook it up. And then when someone clicks on a button, then your code in Python gets ran, right? So this is where we say, because it's cute, we're hooking up a signal and slot. So there's a button called distance. It has a signal called click, and in that slot called connect, we put our Python function called calc distance. That's how we hook them together. Right. So this is an XML file from Qt Designer. Again, another example. So this standard practice, that our interface designed in some XML type language typically seems to be the trend, and then the code is done with a programming, the controller is done in a programming language. And so we have a push button here in that. You can also go Python and quick controls, right? So you could design a UI with code or with Qt Creator, right? It's a .qml file. It looks like JSON, right? Then use Python to load the file, right? So very similar process to bring the file in, right? Just different commands when you're using that as well. And then use Python to connect the code and controls. So find a control, hook it to a particular Python function. That's one method. Another method is to make your Python code look like a cute class and throw it into the interface. That's a little bit more involved, right? So button.click, connect, sum slot. Okay, and so this is actually specking out the interface, right? But it's not done in XML. It's done in something that looks like JSON, curly braces and that. So we have anchors of how to stretch out something. We have a text field. We have buttons and that sort of thing. Now, the thing about QML is actually its own thing. So besides Python tying into QML to do interface stuff, QML actually has its own language, right? This may sound weird and that. And so the interface is designed with code, or maybe not. We could have a good argument here. We love code, the look of it, the taste of it, the smell of it, the texture. It's a gold member play there. So it's a blend of JSON looking stuff and JavaScript. And so what you see is almost going back to spaghetti code. It's kind of weird in that. But you have the ability in one file to spec out the interface and have the code there that responds to someone clicking. Right? Total of language is one, but we could argue, right, are JavaScript and JSON one thing or separate things? They sure feel like different things when you're working with them. But if you spend any time in the JavaScript world, you're going to run into JSON. So you typically pick up JSON through osmosis, right? Simple is sometimes best. However, it could be a hot, sticky mess. Like I said, we could be going back to spaghetti code real quick and that sort of thing. So here I have a column which organizes my buttons on my interface in that. But here on click, I have, hey, this is an example out of App Studio. Get the map view and set the viewpoint with animation, right? And zoom to a particular location in that. So now we're getting back to mixing things. And so within the same language, right, we could be doing MVVM, but also a little bit of MV and a little bit of spaghetti code. And right, so if we're not disciplined, we can make a mess fast. So what I want to talk about now is ArcPro, the DAML and the XAML files. So in the metadata example that in the previous lecture, right? So this is what its view model would look like, the XAML file. So it's got a spot for name type, tags, location, thumbnail, and that. And then when you run it, right, on a map layer, then those things get filled in that. And we get a little thumbnail in that. So this is what it looks like when you're in Visual Studio, and this is what it looks like when it's running with the data populated. So I just want to give you a feel for, I guess, what it looks like, code while you're building it, and then when it's actually running. Okay, so there's this DAML file in that, and this is an ESRI thing. Okay, so DAML files is a like desktop application markup language, and basically what we're getting into is when you want to add a tab, right, or even groups within a tab. So what we're talking about here is the ribbon. So we're adding something to the ribbon of ArcPro. Now here's a section is to comment out this. You take out the little angle bracket, exclamation point, 2 hyphens, there, and then this metadata viewer will go into its own tab. Before it just went right into the add-ins tab in that. And the big thing that all that gets added is this metadata view show button. And so when someone clicks on that, that's going to run the show button, which is going to pop up the metadata viewer pane in ArcPro. And these dock panes are ESRI things, and typically these controls, we're all talking about ESRI technology. Right? And so one is to, the XAML, I actually put it off into a Google Doc so that we could take a look at it in that. So the XAML file is really about building interfaces in Visual Studio. In that. And so the DAML file is from ESRI. This is the full file in that because I couldn't show it all on the screen in that. But notice that it starts with ArcGIS, a little hint that this is an ESRI thing. So DAML, definitely an ESRI thing in that. And it's really about how are we going to add ribbons or groups to ribbons or tab, like how a new tab on the ribbon or a new group within a tab, and then typically buttons or commands to that group, what their tooltips are, and then eventually, you know, when someone clicks that, that'll run some code in the background. So show, right? So there's a doc pane involved in here, the metadata viewer, and that can show up, and then there is the button that gets it up for the first time. Okay. In that. So when someone clicks the button, they're going to show this metadata viewer, which is a type of doc pane, but this is an ESRI doc pane. So that all that, Wolf showed that in one of his previous videos, that, you know, when you drag the doc pane over and you get that, it's going to place and snap in place, you get the little pop-up, do you want to drop it here, kind of stuff. That's all built in the doc pane, so via inheritance, your metadata viewer pane will inherit that. But then where the button is that actually launches it and what group it's in, that's done up here. But this is very similar to the config XML. There's a lot of similarities for an ArcMap add-in, right? because in there you're describing what the toolbar is going to be called, and it's specific to ArcMap, ArcScene, ArcPro. Well, not ArcPro. This one's specific to ArcPro. But it's really about where on the ribbon are you going to land typically in that. And then what kind of panes are you going to be adding to the interface. This is a XAML file, so this gets more into, I guess, the XML that's used to design the actual interface. This is really describes how we're going to drop it into ArcPro on what tab and what group and what buttons are going to be there. And this is more about what the interface is going to look like in that. Border panes and a border brush. Here you can see where it says name, type, tags, and then thumbnail. And notice you'll see binding, right? And then the mode. We talked about one-way, two-way bindings. So this is binding into the model view in that. So if I got to go back here and we can take a look. So name, type, tags, location, thumbnail, right? There's nothing in there now, but over here now we have values bound in there. It is a one-way bind, right? So we're just going to go read what's there. If something changes, this interface won't be dynamically updated. And that. Okay, so this is us defining the binding, but now we've dropped into the .NET MVVM world, and its binding system. And this is your view binding to the view model, okay, that you've designed in that. So let's jump back out to the lecture.
So if you need to re-examine a topic or need clarification on a term or concept, or maybe you just have questions, you can get an answer by posting a note on one of the discussion boards for this course. This concludes this lecture.
So extended time, what I got for you this week. SDK MVVM thoughts. Okay, so DAML, the desktop application markup language, definitely ESRI thing, right? It's all about the ribbon, where you're going to have a new tab, where you're going to have a group within a tab, buttons in that group, and then also panes that will launch typically from there. In that. So you have to be comfortable with hand bombing XML for this file. That sure seems to be the feeling. XAML .NET thing. So it's a Microsoft .NET C# thing. There is a visual designer in Visual Studio, so I would definitely advise you to use it. But sometimes you can't avoid hand bombing XML if you need to fix something, right? MVVM. Okay, you cannot avoid it if you're going to be in the SDK. Doing ArcPro SDK stuff, and also if you're going to jump onto the mobile side and start doing Android development, hey, and you want that cool landscape portrait, switch out the views, landscape portrait, don't lose the data, landscape portrait, live data, all that kind of stuff. So if you want all those benefits, that comes with this MVVM pattern, right? MVVM also helps ESRI unit test ArcPro, so they can do as much automated testing ahead of time. So they catch they catch easy bugs, we'll say, bugs that the end users would have caught anyway. So you squash as many bugs as you can ahead of time, because once you get humans testing, then that's expensive, right? So if we can get the computer to test stuff and find things that we get them fixed, clean code, that sort of concept, we definitely want to take advantage of that as much as possible, right? ArcPro is also built in .NET C#, so some of this ESRI might have been forced into, right? And that the MVVM pattern, but it does have benefits for them, especially for unit testing. That's all for now.